Lecture 3.3, multiplication with, again, fractions, and the area of a triangle. Well, let's start on page 183. Talk about a couple rules here. The first one being the rule in the middle in yellow. The product of two fractions is the fraction whose numerator is the product of the two numerators and whose denominator is the product of the two denominators. Alright, so basically what they're saying here is if we take two fractions and multiply them, our numerator is going to be the product of our numerators. Product means multiply, so 3 times 2, 6. Our denominator will be the product of the denominators. Multiply, 35. So 3/5 times 2 over 7 will give me 6 over 35. And then once you do that, you need to determine if that 6 over 35 will reduce. So if we, like the last section, break these down into prime factors, and this one into 7 times 5, do we have any commonality between the numerator and the denominator? Nope, no numbers that are similar. That being the case, we're done. Alright, so that's basic multiplication. Let's try a couple that might give you a few questions. Alright, a fraction times a whole number. That 5 is not as a fraction, but all you have to do to make it a fraction is to put it over 1. Now you have two fractions that you're multiplying. Numerator times numerator, denominator times denominator. What I see happen many times, and this is the reason why I put the 1 here, is I see students take something like 3/8 times 5 and multiply the 3 times 5 and get a 15, and then the 8 times 5 and get a 40. And that's why I put it over 1, so you know that the 3 is with the 5 only, and then the 8 is with the number on the bottom, in this case the 1. So that's just to keep you from making a simple mistake there. Example 3 on page 184, it gives us 1/2, and then they give us in parentheses a 3/4, 3/4 times 1/5. Now if you remember from PEMDAS, we do what's in the parentheses first, so we're going to multiply these guys first and get 3 times 1 is 3 over 4 times 5, which is 20. We're going to leave those in the parentheses and multiply that times 1/2. Now when we multiply this times 1/2, the only difference between this and this is a symbol for multiplication, and by not having a symbol, it means multiplication. So the difference is just in the symbolism. This is a symbol here, and the parenthesis acts as a symbol on this one. So it's done the same way. So you're going to get your numerators. 1 times 3 is 3. 2 times 20 is 40. And then you can write this as a product of primes if you want. 3 times 1, and then we've got our 2 times 2 times 2 times 5. Nothing common up here with what's down here. So this is our final answer then. It can't be reduced, and that's all we can do with that. Alright, so let's continue on. Let's try one like 1/3 times the quantity 3x. Again, we have a whole number. Make sure you don't make the mistake, so we're going to rewrite it as a fraction, all of it over 1. Now we know to multiply the 3x times the 1. Anything times 1 is itself. And then 3 times 1 is 3. Well, now we can see that we have a number on top and a number on the bottom that's the same, so we can get rid of it. Now our answer is x over 1, or we don't really even have to show this x. We can just call it, or this 1, we can just call it x. And be good there. Let's try one with parentheses, where we're using the distributive property. Let's do 1/3, and we'll take our parentheses and we'll put a 3x minus 12 in there. If you remember from PEMDAS, we do what's in the parentheses first. We can't combine anything in here. Remember a few sections back I said if there was a variable or a letter in one, and it had a variable or a letter in the other one, or not at all, you can't combine those. You can't add or subtract them because they're not like terms. So we can't do anything with that. All we can do at this point is use our distributive property. When our distributive property says that we take 1/3 times each term, and we have two terms because they're separated by our minus sign here. So we're going to take our 1/3 times 3x. So 1/3 times 3x over 1, and then we're going to take that 1/3 times, we'll do the 12 over 1. So we're taking this times this and this times this. With the minus sign, we're going to drag that guy down there. So 1/3 times 3x over 1 gives us, multiply across, minus, multiply across here, 12 over, multiply across here, 3. Alright, so we have 3x over 3. These are two separate entities, so you can work with one piece at a time because of this plus or this minus sign here, plus or minus sign. So let's look at this fraction. We have a 3 over a 3. 3 over 3. Any number over itself is 1. Well, let's cross this out. Let's divide 3 by 3 and get 1. And this is actually 1x. So let's put that in a different color here so we know where part of our answer is. Now we have 12 over 3. Well, let's write that as the product of primes. 12 can be written as, let's cross it out and write it as 2 times 2 times 3. Well, 3 is a prime number. Can't do anything with that. But since we have a 3 here and a 3 here, we can divide out, and we're left with 2 times 2 is 4. So our answer to this whole thing here, our simplification of this whole thing, is just x minus 4. We distributed. Then we looked at what was common in our numerator and denominator, divided out, got it just our x. We did the same thing here, 2 times 2 times 3. We took our 12 down to its prime factors, and lo and behold, we had a 3 down here, so we were able to divide these 3's out and get rid of them, leaving us with 2 times 2, which gave us that 4, and our minus sign here. So, a few little twists when you're doing multiplication with fractions. Let's keep going here a little bit. Let's do 15 over 8. And let's multiply that times 4 times 9. Alright, multiplying this out, we get 60, 15 times 4, over 8 times 9, because you know your multiplication table so well, 60 over 72. Well, we know that both of these are even, so I'll say, oh great, now I've got to do the prime factoring thing. So 60 can be written as 2 times 2 times 3 times 5, because 2 times 2 is 4, times 3 is 12, times 5 is 60. 72 can be written as 2 times 2 times 2 times 3, 8 times 3 is 24, times 3 is 72. So we got our answer. Now we're trying to reduce it. Wrote out our product of primes, we divide, and we divide. Which gives me as a final answer a 5 over whatever I don't have crossed out here, 2 times 3 is 6. And I'm good to go there. Alright, so let's keep plugging along. Let's try this one. Let's do a negative in here. We need some of those practiced once in a while. Negative 8 over 18. Remember, multiplying negatives automatically makes them positive, so that gives us 72 over 36. So as you're looking at that, 72 over 36, you notice they're both even. We can reduce those. 72 can be reduced down to, well, 36 and 2, right? Whoops. Let's make it like this. And then 36, let's just write it here. If you notice, I have a 36 here and a 36 here, so rather than doing the whole tree, I notice that if I just break it down into 2, divide it by 2, I get the bottom number. Well, I can automatically then cross these 2 out, save myself a lot of time of factoring that down, and I'm left with 2 over 1 or 2. Alright, I'm going to go ahead and shut this off. I'm running out of time. We'll go into a 3.3b lecture and we'll go over a few more.